Okay, if not 14th, can you guys solve question number 9th? Have you solved these questions or do we need to solve them? Because I don't think we have covered them in the last class. We only covered theory, correct? Okay. Let's start with fourth question first.
So question number 9 got the answer.
Okay, how will you solve question number 9?
I just added a vector plus b vector
Okay,
and took it as c vector. So now they're asking us to find the c vector cap, which is
Okay.
c vector by modulus of c vector.
correct. It's that a vector A is given, let's say, consider A vector which is I plus j plus k, right? And it is equally inclined to OX, OY, OZ. Now, if you remember cos alpha, what was cos alpha? The angle, cosine of the angle, cosine of the angle made by vector A with x-axis. X-axis means OX, basically. Similarly, cos beta over cos gamma is for OZ. Right? Now, how do you find DCs? These were called direction cosines. So DCs. So how do you find cos alpha for this vector A?
We can, from the vector, we can find a is equal to 1, b is equal to 1, and c is equal to 1, which are direction ratios. So cos alpha is equal to L, which is a by root of a square plus b square plus c square, 1 by root 3.
Correct. And similarly, cos beta will also be 1. Is equally inclined to axis, all the axes. Can you guys solve question number 17? show that the points A, B, and C with position vectors OA, which is named as A vector, is equals to 3i minus 4j minus 4k. B vector, which is basically OB vector, 2i minus j plus k. And C vector, which is OC vector, I minus 3j minus 5k, respectively, from the vertices of a right angled form, the vertices of a right angled triangle. So you have to show basically these three are the vertices of a right angled triangle. How can you solve any triangle as a right angled triangle?
We can use distance formula first to find, you can say BC square is equal to AB square plus AC square. And BC square could be BC, we can find it by taking the distance formula by vector B and C.
Correct.
Like that we
So
can do for AB and AC.
correct. So how do I find out AB? Just tell me that. What would be AB?
2i minus 3i plus
Which would be minus I.
minus I plus 3j plus 5k.
And similarly, you can find out
BC
AC.
is equal to
Yeah.
AC is equal to minus 2i plus j minus k. BC is equal to minus I minus 2j minus k.
And we have to find out the modulus of
Modulus.
AB would be
Root 35.
Similarly,
root 6 and root 41.
so in this case, BC square is equals to AB square plus AC square. Yes, so we are good to go for, no, let's solve question number 18 as well. In a triangle ABC, which of the following is not true? So you have to, first is AB plus BC plus CA is equals to 0. So AB plus BC, okay, plus CA is equals to 0. Is it correct? Yeah, I think it should be correct, right? Because they are following the triangle rule of addition. AC is equals to AB plus BC. Hence, if you no, I don't think it's true because AC is equals to AB plus BC in this case, right? So option first is not true. Let's check option second, AB plus BC. Oh no, it's written in C. Yeah. So first is AB plus BC is equals to AC, right? We have this. So first is written, if we take minus CA and take minus CA towards the left hand side, we'll get the first equation. Now second is based, if we take AC, just the left hand side. And third is also the same. I think second and third option is same. Is it so?
Yes, sir.
Yeah. And last is AB minus CB. Okay. I guess all the options are correct. Yeah. Okay, so let's proceed with the next part. So the last part of vector involves product of two vectors, right? Product of two vectors. So two product or rather multiple product can be multiplied using 4 ways. But in your syllabus, it it is only, I mean, there are only 2 ways given. But if you check your last pages of NCRT, so it's being given there, one of the type of product, scalar product. So scalar triple product. But I don't think that is in your syllabus. So we will be studying about 2 basic type of product. First is known as scalar product or dot product. Right? Second one is vector product or cross product. Now, as the name already suggests, The scalar product is a type of product in which the output is a scalar quantity, and vector product is such a product in which two vectors will multiply to give you another vector, right? Now, what are their physical significance and how do we do them mathematically? We'll understand both of them, right? So first is scalar product. Let's remove this thing. So first of all, let's say we have two vectors. Consider A, and A is A1 I cap plus A2 J cap plus A3 K cap. Similarly, some vector B, where B is B1 I cap plus B2 J cap plus B3 K cap. Then A dot B signifies the dot product of A and B, right? A dot B is the dot product of A and B, and its value can either be written as mod of A into mod of B into cos theta, or so just remember this. There are two formulas for calculating A dot B, either mod A, mod B, cos theta, in which case theta would be the angle. Theta would be the angle between A and B, right? Where theta angle between A and B. Or if vectors are given in component form, so let's say you have your two vectors. In that case, dot product is very simple. You just have to multiply the corresponding elements. So I with I, j with j, and k with k. Right? I with I, j with j, and k with k. So your dot product would be A dot B is equals to A1 B1 plus A2 B2 plus A3 B3. So it's a geometrical representation of the two vectors, in which vector A is something like this and B is something like this. So they would be inclined with each other at an angle theta. So if that angle theta is known and the magnitude of the vector is known, then we can find out A dot B using this formula. Or in most of the cases, you will be given the vectors only. So if vectors are given directly, then A dot B is very simple. And you can understand it very easily. Like, let's say if you're multiplying A dot B, what does that mean? You are multiplying each component with each other component, right? So when you multiply A1 I cap with B1 I cap, you're multiplying I with I. So I and I are same vector, right? Same vector has an angle 0, right? I and I, positive, both positive, right? So if they have angle 0, so they will multiply using this rule. A dot B is equals to mod A into mod B into cos theta. So mod I into cos 0. Mod I is 1, mod I is again 1, cos 0 is again 1. So that would be 1. I dot I would be 1. But if you multiply I dot J, in that case, theta would be 90 and cos 90 is 0. So if two vectors are perpendicular, this is the important result. If two vectors are perpendicular, in that case, the dot product would be 0. Right? And similarly, I dot k would also be 0. J dot k is also 0. So a1 b1 plus a2 b2 plus a3 b3. That would be the value. In most of the cases, vectors directly would be given, and a dot b would be very simple to find out, right? And in some, let's say, so let's find out this. This this is a vector. So what is the value of a dot b? A is given, b is given.
15.
Got it. What's the value? What's the angle between them? No, angle is not given. You have to find out that. So angle between them is cos theta. I mean, you can only find out the theta using cos theta. So you do know A dot B. And you also know the vector A and B. So you can find out the magnitude of A and magnitude of B. So using this formula, this one, you can find out the value of cos theta and the value of theta as well. So cos theta would be A dot B divided by mod A mod B. A dot B is 15, 15. Divided by root A mod A.
Root 29 and root 11.
Yes. And I don't think we can simplify it more. So cos theta is 15 by root over 319.
319.
Or we can also write it as theta. Theta is equals to cos inverse 15 by root over 3. Right. So now let's talk about some of the properties of scalar product and application of dot product. I mean, how can we further use it? So one of the particular cases, can I remove this? Someone is
Yes.
writing. So one of the particular cases when two vectors are equal, so A dot A in that case is mod A into cos 0, because the angle between the same vector is 0, right? So cos 0 is 1 and mod A into mod is mod A square. So A dot A is mod A square. This is one of the important property of dot product of two same equal vectors. And also it is commutative, that is A dot B is equals to B dot A, because it's a scalar quantity. It is scalar quantity, so it will be numbers. So it doesn't matter whether you're multiplying A first or B first. Yeah. Similarly, lambda times A dot B, scalar multiplication of dot product is similar to the simple multiplication with vector, or it can also be written as this. So lambda can be taken with A or B. After dot product, we can also find out the, first of all, what are we finding out with dot product? So that is basically projection of a vector on a line. So let's say we have these vector A and B are situated like this. So this is A. This is. So if I talk about shadow, so this length. So let's say this is some A, this is B, and this is C, and this is N. So AM, this AM is the shadow of AC, basically B vector, shadow of B on A. Okay, just a minute. Yes. So we were talking about projection of a line, projection of a vector on a line. So we have taken this vector B and A, in which the angle between them is theta, let's say. Right? If we talk about the shadow, shadow is basically basically a synonym for projection only. So if we talk about the shadow of B on A, so this would be the length equal to AM, right? And AM is basically the perpendicular from C on A. So this would be the shadow, or rather projection of B on A, right? So to find out the projection of a vector on other vector, you have to take this much amount of distance and the direction towards A. Right? So AM can be found out using vector B and angle theta. Right? Because so let's say we have to find out the length of AM. So the length of AM would be, or rather magnitude of AM would be it can be found out using angle cos theta. So cos theta is equals to base by perpendicular. So AM divided by AC. Hence AM would be AC cos theta. In fact, mod of cos theta because AM can't be negative. Right? And if you want to find out the vector AM, we can easily find out using unit vector of A, because unit vector is supposed to give us the direction towards A, right? And it has magnitude 1. So the magnitude will be equal to the magnitude of AM, which we can find out using vector AC. Vector AC will be given vector B cos theta. And if you want to find out the vector AM, so vector AM would be the magnitude of AM into A cap. So the magnitude of AM into A cap, right? And magnitude of AM would be how much? AC cos theta. So it would be B, the length of B, right? Cos theta into A. Rather A cap. Right? Can you use dot product to write a projection of a turn line? How can you introduce dot product here?
Projection of A vector on B vector can be written as A vector
Yes.
dot B vector divided by modulus of B vector.
Correct. And how can you do so? I mean, using this, can you write that? Using this and using the previous formula. Do you have the value for cos theta? It was
Cos
A dot
theta.
PTO. Yeah.
Yeah. Cos theta is A vector dot B vector divided by mod A mod B vector.
So this cos theta can be written as A dot B divided by mod A mod B. So this is A vector. So this can be cancelled out. This will be written as A dot B divided by mod B. Just a minute. Yes. So it can be written as A dot P. Actually, yes, this was B cos theta. So can be written as B dot P divided by mod A. But we are writing out the projection to it. So I'm small. So I think we have done something wrong. Cos theta would be AM by AC. AM would be AC cos theta, correct? And we have to find out the projection. So the projection is given as B vector dot A cap. The projection is not given as this. Projection is given as this vector will be defined as B vector dot with A cap. B vector dot with A cap would be equal to it. I mean, it can also be written as B vector dot with A vector divided by mod A. Right? So it can also be written as A dot P divided by mod A. Right? So projection is given as this. So you have to take the vector itself and the unit vector along the line. You need the projection of, right? So if you are taking the projection of B on A, in that case B vector dot with A cap. And if you're taking another P and Q vectors, let's say, so this is Q, this is P. Can you find out the projection of Q on P?
Q vector dot P vector divided by mod P vector.
Correct. And P on Q?
Q vector dot P vector divided by mod Q vector.
So that is how we can find out the projection. And if theta is equals to 0, right? If you are finding out the projection of a vector on itself, right? And in case of theta is equals to pi also, the projection will be itself, right? Because the projection of the same vector, that is shadow of the same vector on same vector, is the another same vector, right? And in case of perpendicular vectors, the angle would be 90. So cos 90 would be 0. So perpendicular vectors will have projection 0. Right? Perpendicular, it also means that the perpendicular vectors will have no shadow. Right? So if the object is standing perpendicular, the shadow will be just behind it. You wouldn't be able to see it. Okay. It's also given about alpha, beta, and gamma, the direction angles of vector A, and then direction cosines can be find out using this cos alpha and cos beta and cos gamma. We already know that. Okay. So first of all, the real application of dot product is to show two products. I mean, to show two vectors perpendicular. So if two vectors are perpendicular, it means the angle between them is 90, and hence cos 90 will be 0. So most of the times when you have been asked, or rather you have to check. So in some of the cases, you will have also have to check that whether or not these two vectors are perpendicular. So in all such cases, you will have to find out the dot product of those two vectors. So two vectors are perpendicular or not. A dot B should be 0 if they are perpendicular. Unless they are non-zero. This is the important one, one important application of dot product. So let's solve some questions based on exercise 10.3, page number 447. Let's start with question number 2. Find the angle between the vectors. First of all, find the angle. What's the angle between these two vectors? What is the value of A dot B? What is the value of their dot product?
10.
Yes. And what is the value of their mod? Individual modulus?
Root 14.
Root 14. And I think each is root 14. Right? So
Yes, sir.
makes them 14. So 10 by 14 is 5 by 7. So the angle between them is cos inverse 5 by 7. Okay, let's solve question number 11th. Show that this. So you have to tell me how to show it. First of all, you know how to show it. So show it. There are two different vectors are given. One is A mod modulus of A. So this is a scalar quantity. Into B vector, this is a vector quantity plus mod B into A vector is perpendicular to mod A B minus mod B. How can we show two vectors perpendicular?
Dot product of these two vectors should be equal to 0.
Correct. So if you find out the dot product of them, what would be the term? What is the simplified expression we will get after the first step? You'll have to multiply each term with each term. Right? So first term with first term first. Mod A, both are scalar. So it becomes what? Can you tell me? Mod A square into B dot B. If you multiply first term, then you get this. Now, what is the value of B dot B?
Mod B square.
Mod B square. So it becomes mod A square into mod B square. Now the second value will be minus A dot B, mod A mod B, A dot B plus mod A mod B, A dot B, and the last term would be minus mod B square. And similarly, A dot A, that will become mod A square. Okay. So they get cancelled with each other. We have to show the dot product of both of these vectors have to be 0, which is in this case. Hence, these two vectors are perpendicular. Okay, can you solve fourth? To find the projection of the vector I plus 3j plus 7k on the vector 7i minus j plus 8k. If you want to find out the projection of a vector, let's say I plus 3j plus 7k is a vector on the vector b, which is 7i minus j plus 8k. So how can you find out? I plus 3j plus 7k and this is B, 7i minus j plus 8k. We have to find out the projection of A on B.
A dot B by modulus of B.
A dot B by modulus of B. And the value would be 60 by
Root 114.
sixty by 2 equal. Let's solve question number 6. Find mod A mod B if A plus B dot A minus B is equals to 8. And mod A is equals to 8 times mod B. You have to find out the value of two variables, and you have been given two equations.
Mod B is equal to 2 root 2 by root 63.
And in that case, mod A will be
16 root 2 by 3 root 7.
okay. Can we also solve 9th? Find mod x if for a unit vector A, x minus A dot x plus A is equals to 12.
Root 13.
Correct. I just want the value for 13th as well. find the value of you are given that A, B, C are unit vectors, and you have also been provided one of the equation A plus B plus C is equals to 0. A vector A plus B plus C is 0. You have to find out the value for A dot B plus B dot C plus C dot A. How can you use this equation A plus B plus C is equals to 0 in the proof? I mean, in the value that you have to find out.
We'll multiply that equation with A vector, B vector, C vector. And it's also
Okay.
given that A vector, B vector, C vector are unit vectors. So if you multiply that way, that means A vector, B vector plus C vector, A vector is equal to -1. So in all these cases, you will get -1 as your RHS. So we can add all of them.
But how will you find out? Okay. Cool. Or we can also do one more thing. We can find out the dot product of A plus B plus C with itself. A plus B plus C. If we do so, we'll get 9 terms at first. But if you solve them, they'll be repeating. 3 terms will be repeating, and 3 will be -3. I mean A dot A, B dot B, and C dot C. So in that way, you can find out the answer in one calculation.
So I got the answer.
Yes,
-3/2.
yes, -3. Okay. So this question number 16, I mean 15, 16, and 17 will be using the one concept only. I mean, if you have to show these points are collinear, you can easily show that using the distance formula or using the I mean, we are using the distance formula, and then again, right angle triangle can also be shown by dot product. If you take the dot product of those two sides, the answer would be 0. Right? I just want the explanation for question number 14. If either vector A or B is 0, then A dot B is equals to 0, right? So if either of the vectors A and B are 0, then A dot B is 0. Right? We know that. But the converse need not to be true. Justify your answer with an example. So you can just tell me the procedure. How can you solve that? And give me an example. What's the best example for this case? It is basically saying that if one vector is 0 and you take the dot product of two vectors in which one of them is 0, then dot product is 0. But if the dot product of two vectors is 0, it is not necessary that one of them has to be 0.
Because A vector, the dot product of A vector dot B vector is modulus of A modulus of B cos theta. So if theta is 90 degrees, then the answer will be 0.
Yes, so in all of the cases when two vectors are perpendicular, the dot product will be 0. Can you give me an example? Very easy example. I dot j. I and j both are perpendicular. I dot j is 0. Right? But I and j are not 0. Okay. So we are done with dot product today, and we will start a vector product in the next class. Okay. We can leave the class.